Hello everyone and welcome back. It's Jason again. We're going to watch part 2 of this video. So if you haven't seen part 1 yet, click on the link in the description, or if you're on Udemy, just go back in the course. Now in part 1, we talked about how to solve problems with code and sort of what this development process looks like. And we broke it down into 5 different sections. So part 1 covered the first 3, which was inhale, investigate, and prototype. So now we are going to watch the last 2 sections, which is test and inhale again. So let's switch over to Steven's video here, and let's go ahead and continue the rest of this.
I used my magic spell just now to take that illustration.
We're testing the function that Steven wrote about changing the speed of clips.
From yesterday and speed it up by a factor of 16, and again by a factor of 32, and once again by a factor of 64. So each one is twice as fast as the other. Now I can easily nest one inside the other, or do whatever creative things I want with them. The fact that I am able to hand edit the
I'm going to stop there. He said to do whatever creative things he wants with it. Now let's think about this. Let's think about other creative uses. Right now, Steven's kind of rearranging these pictures in pictures, and he's gonna have one that's like twice as fast as the one below it, and then there's one more that's twice as fast as all the other ones below it. Having a convenient way to slow clips down or speed things up, that's pretty convenient in like video montages that we see pretty often in YouTube videos. One of my favorite things to watch are like gaming PC build videos, and a lot of times they record the entire build process. Now that's a long build process, so they'll speed up the video to fast forward through lots of things, and it's quite entertaining because you're like, well, it looks like they're building it super fast, but there are some moments you want to go back to real time to slow it down. So having a quick way to sort of have sped up videos and then slow down videos, so you can see like like maybe the internals of the computer, or the actual part where you're putting the processor into the socket. We want to see that, not sped up. So there's other creative ways to make use of this function that Steven wrote. So let's see what else Steven has to say.
Outputs of my own code creatively inside of Shotcut means I have successfully integrated coding with my creative pipeline.
And that's a powerful thing right there, just being able to integrate code into your creative pipeline. Now, this is not necessarily like, integrating code into an app or a piece of software or a website. It's just his creative process. And another example of that would like be 3D designers or 3D modelers. They're not necessarily coders, but they design things in 3D. If they use Blender, which is a pretty popular 3D modeler, they use Python to automate rendering processes. So they'll use some code to help speed up their process, so they don't have to like spend all this time doing sort of the tedious bits and the nitty-gritty. Other places, maybe something that's like not inside a computer. Maybe if you were a wedding planner, maybe trying to figure out all these dates that conflict with each other and trying to make them not conflict. Maybe that's a long process, but maybe someone could write an app or write some code that will automatically manage some of the scheduling for you. That's another powerful way you can like integrate code into your process. So let's go ahead and continue this video.
And just to complete the test, let's watch some of this weird video I just made. As you can see, the innermost box is the fastest, and it will repeat 4 times. The middle box will repeat 2 times, and the outer box is, actually not going to finish before we... Here, I want to leave you with 2 parting thoughts. First, to anyone who has ever taken a traditional coding class, you have gotten a lot of practice on the how. But the why is half the design cycle. Now,
that is a good point, like the why, and we talked about this in the other video about how versus why. But in traditional education in college, when they're teaching computer science, a lot of students don't really know what they're going to do, or what kind of job they're going to get, what kind of projects they'll work on, what kind of problems they're going to solve. So they don't really know the why, and so all we have to focus on, and it's how it's taught to us, is the how, like how to solve these typical problems, how to write this thing, how to code in this language. But we definitely don't think enough about the why. Now, in the real world, you start with the problem. You have something that you want to solve, and just trying to solve that problem gives us all the whys that we need, and those whys drive us and give us more questions to ask and help focus us in the right direction, right? And so that's what Stephen's getting at here. Let's hear what his second thought is.
99% of coders that I meet are great on the exhale, but they gasp for breath on the inhale, and they faint from lack of air when you ask them to do anything remotely creative. Second, did you bring your paper? Go look at the code linked below. Can you draw a picture of how the two files that I wrote interact? Can you draw a picture of how the pieces of code within a particular file interact? A lot of students try to learn how to write code before they've learned how to read code or think on paper. Spend a few months trying to read and think about somebody else's code, then try to learn how to write. See how that changes things for you. It will.
Yeah, so learning to read before we write, and sometimes it makes sense, and sometimes like we learn things backwards, like maybe learning to play an instrument. There's many that like learn to play notes before they learn to read music sheet, right? And that's pretty typical because sometimes learning to read music is kind of hard. But I would say if you did do it the other way and learn to read music first, you'd have a better idea of how like scales are formulated, like, you know, the whole, whole, half, whole, 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 half. And so I played the trumpet. And so when I learned to play the trumpet, you learn your scales, and you learn all the finger positions. And I imagine knowing the scales ahead of time before learning all those finger positions, that would actually help a lot, just to help understand why it is that way. So let's do a little exercise here. Stephen gave us a task. He said to pull up this link. I do have that link open here, and that link will be in the bottom of the description or on the Udemy course. And instead of doing this on paper, now you should have paper. I'm gonna use this whiteboard app here, so that you can see better, because I don't have the greatest lighting here. And this is a GitHub commit. This shows like these. Stephen mentioned 2 files, but there's actually 3 files here. One is a README file called readme.md, and the other 2, one's called demo.rkt, and then util.rkt. Right now, let's go ahead and draw some boxes here. So I have, let me type RR, oops, didn't work, RR, there we go. Now I can draw a box. I'm going to draw a little box for my README file. And I want to do an example with this README file, so I'm going to draw a little box of our GitHub output. And I'm going to put some text right here. I'm just going to call this readme.md, right? And this has some content in it. It's a description of what this project is about. So I'll go ahead and do a couple scribbles to represent there's content in here, okay? And on this side, I'm going to call this the GitHub main page. So I'm going to say github.com/sr or I'll just do ... right? And this is going to be the render page. Now let's see what I mean by that. Let's go ahead and go back to the home here instead of the commit view. And this is the home page of Stephen's repository here called Coding versus COVID-19. And this content looks familiar. This is the content of that README file, and it just shows up on this little index page in this nicely formatted card here with this little icon. So I'm going to draw that right here just to represent that, and I'm going to freehand this just to represent it's like this rendered out thing. So the boxes are the files, and then this has a thing here, and then it has like README, and then it has a cool little book. I'll try to draw a book here. There we go, an icon, and it has those words written here, and that content comes from over here. So I'm going to go ahead and draw an arrow. So I'm going to type AA to pull up the arrow mode and draw an arrow that goes from here into there. Yeah, so the README file, because it's called readme.md, automatically gets injected into this nice card on the index page. And that's how I'm going to think of my diagram. So let's go back to Steven's exercise with util and demo here. Now, instead of the commit, I'm just going to go ahead and click on the files because it uses a different syntax highlighting. Let's go ahead and start with the demo here. And we have some code. This is racket code and has a require util. Hey, that looks familiar. That's that other file. So one file requires another. So I'm guessing the arrow should go from util into demo. So let's go ahead and draw two boxes. I'll make them different colors. Let's do blue. All right, so we have a thing here and a thing here, and let's go ahead and name them. This is going to be our util dot. Oh, can we change the color right now? Oops, I guess I have to choose a color first. Let's just leave it black. Util.rkt, and over here we have demo.rkt, and this whole file goes into demo, but we'll take a look at that file in a second. Let's just draw an arrow for now of this file, arrow, this file going into this file. But we're going to get a little bit more specific than that, because right now we have util. There's our speed up function. So let's go ahead and write in here that we have something called speed. And I'll actually write the function speed up clip speed, right? And it does use some things in here. There's something called video file length, scale video length, and video length to string. And then it has the XML, which Steven mentioned. This writes the other language for us. So let's go ahead and look at what's in util.rkt. So we'll go back here, and then util is right there. And we have this thing called provide. And it provides these specific things: video length, video file length, scale video length, and scale video length string. So I'm going to write those out right at the top here. And these are provided, so I'll just name them out: video length string, length string. Now these are being provided, but that doesn't necessarily mean they're all being used. So let's go ahead and flip back. I'll be flipping back and forth because that's this task. We're trying to figure out the relationship between these two files. Now in demo, I can see video file length. That's this one, that's being used. Scale video length, that's this one, that's definitely being used. And video length to string, that's this one. Now what about scale video length string? Is that being used anywhere? Well, we can do a little search. I just did Control F and scale dash video dash length dash string. So it's not even used in this file. So that last one's not being used, even though it's provided out. But these other ones are. So let's draw some arrows that look like this. So let's try color coding this. I'm gonna make this red because it's going out into this file. So these three, all three of these are needed to make this function work. Cool, so we have this relationship between these two files. That was Steven's first task. Now he gave us a second task. He said, can you figure out the relationships within one of these files? Now, I'm guessing it's gonna be not this demo file, but the util file, because it stands for utility. And this has a lot more code in it. So these are some things that are defined. And if I look down, I guess they're functions, because here, look, define video file length, that's that one. Let's follow the breadcrumbs here. So we have video file length that gets provided out, but it uses in something called video file length string and also video length string to video length. So I'm going to write those two right down here, and we'll make these blue because they're internal and they're not being provided out. So video file length string and video length string to video length. Those are two things that I'm assuming are needed for this one. So I'm going to draw some arrows that go from here to video file length, and also from here to video file length, right? And then we can look at video length string to video length. Hey, that is right here. It's the next thing. And it does some things, and it does all of this. Cool, so that goes into that. Now what about this other thing? Video file length string path. So I have a bunch of things defined down here, and there's video file length string path. And so it is defined in here, and it gets fed into that function, which gets provided out. Cool, so there's a couple of other things in here, like we have this video length total microseconds, and that gets used somewhere. Let's see, total microseconds. And that gets used in the scale video length. Hey, that's something that's used here. So in scale video length, we would have another one called total microseconds that feeds into that. I'll do some of this right now. So I'll say video length to total microseconds. And that gets fed into scale length. Yeah, I've got crossing arrows, but that's okay. That gets fed into scale length because we can see that right here. Scale video length needs video length to total microseconds, which is that thing we saw up here. So I'm going to stop here, but the next step would be writing all 4 of these out, and those would feed into this function. So those 4 feed into this feeds into that feeds into that. And we can see how all these things connect. And this is a good way to note take and visualize things, right? So I'm going to end there. If you want to continue expanding your notes, you can. You can even finish and get every single function in this file. Make sure you have lots of space in your paper. You can even start abbreviating these things. You don't have to write out the entire thing like I did here. You can start doing some shorthand for it. And so that's our hands-on activity for you. And let's go ahead and switch views here. If you are on Udemy, we have some assignments for you below. For everyone else, thanks for watching, and we'll see you on the next video.